where new capabilities are coming to market that we really didn't have in the last 20 or 30 years. We thought about them, we played with them, but now they're becoming real for everyone. And there's a set of them: mixed reality, augmented reality, virtual reality, artificial intelligence we'll spend some time on today, quantum computing. There are other areas, blockchain, IoT, et cetera. And they will be what the next generation builds on. So when we take our 19 and 20-year-olds coming out of school and say, hey, what are you going to start with? You know, we started with compute, networking, storage. They're going to start with VR, AI, quantum computing, blockchain, and more. And so it's going to be a different world in 30 to 40 years. The nice thing with all of these sort of capabilities is they build on each other. Mixed reality builds on top of artificial intelligence. It's a heavy user. AI is going to build very heavily on quantum computer. We need it for scale. So they're all interrelated. I thought I'd sort of get us going this morning, wake us up. We'll use a little bit of mixed reality. It's a heavy AI user, and it's a nice way to get the day going. So I'll run a little video, get us. And it's super early. Mixed reality, Halo. I don't know about everybody else. That's going to be the fun for me. So a little bit about how we got here. You know, why are we at the right spot today? We've been through multiple industrial revolutions: steam, electricity, electronics, and IT. We're in the middle of what a lot of people talk about as digital transformation. And it's really sort of three things. It's that compute, storage, networking, and what it's brought about. When I started at Microsoft, first computer was a 286, and all we thought about or asked for was more compute. 286 to 386, 386 to 486, 486 to Pentium, add a GPU, et cetera. We're all pretty happy today. There's a good amount of compute available in our phones, out there everywhere. As we got more compute, we needed storage. 5.25 to 3.5. If you're old enough, you remember the iOmega drives, onto thumb drives. We're doing pretty good on storage today. We'll obviously need more, but again, a lot of progress. The third was networking. Come here 15 years ago, take your laptop, get out the phone line, stick it into the side of the phone, dial 9, hope you can get connected, see what baud rate you could get. So 2G, 3G, 4G, coming to 5G now. So we're getting to the point compute, storage, and networking have sort of changed the fabric. We started with client computing, client-server computing, add in the web. Now people talk about cloud and mobile, or intelligent cloud and intelligent edge. And this paradigm shift has led to every industry being under some point or part of transformation, and/or every startup essentially trying to disrupt what's out there today. So if I go to I was at a sports event before, you talk about what can you use technology for with the athletes, how do we reach fans that aren't in the stadium, how do we better reach the fans that are there, how do we run the business. Next day, go to a media conference, you look at sort of who creates media today, who distributes it, where you watch it. It's all changed from where it's been. Healthcare, telcos, banking, every industry is sort of heavily vested in what can I do with sort of cloud and mobile or cloud and edge, and how does it transform the business that we're in today. At the same time, everyone's also thinking, okay, with those building blocks and where I'm going, how do I start to think about AI or artificial intelligence and weave that in? How do I think about potentially AR? How do I think about blockchain or some of these new areas? AI, we're early in the journey. For us at Microsoft, we think about AI as amplifying human capability or amplifying human ingenuity. How do we help people do more? It's always been sort of one of our core areas of focus or our values, and AI really brings that to life. Lots of definitions around AI. We should assume at some level reasoning over very large sets of data. People talk about machine learning, people talk about different techniques, but large amounts of data, then getting understanding from that data, being able to interpret it, and then in some way moving from reactive to proactive. And then the last part is interacting with humans and making it a little bit easier. A simple moniker that Bill used a long time ago was that today we all learn how to use computers, or as technology advances, we learn how to use our phones, we learn how to use TVs, all types of electronics. When those devices learn how to work with us, when it's the opposite, it's the right kind of paradigm change, so that the interaction model is one where the devices understand how we work and it becomes very natural. Now, for AI, we're at a point where it's the center of the conversation. So what's the change? We have the compute storage networking, we've built it out. For AI specifically, it's three things. It's compute at scale, it's the cloud. Right? You got a good background on cloud from Scott and Scott over the last couple of days. That ability to operate at scale for any developer is requirement number one. When I came out of university, my roommate when I came out of college was a Lisp programmer. Where did he go to work? He went to work at Lockheed. Because unless you had the compute available to work with the tools you needed for AI, you weren't doing anything. And AI takes a lot of compute. That's that relationship back to quantum later. And so compute at scale is thing number one. That means every developer around the world now has access to what they need. The second is data. The truth is you need large amounts of data to build models, to train models, and to enable AI to come to life. And for that, it's been a long journey to get to it. But if you look at data today and sort of that which is created by us, Twitter, Facebook, Yelp, name your social feed, and devices, the growing number of intelligent sensors and devices, at the edge and that we work with is creating the amount of data or the amount of the data necessary to sort of build and train models. And so, at Microsoft, obviously we participate in the cloud. On the data side, not only do we allow people to work with data, but we have data we can bring to the party as well. So Bing gives us a phenomenal data set to work with to train some of the original models that we need to bring AI tools to life. The Microsoft Graph, or the information that comes from Office and over time Windows and LinkedIn, provides another rich set of data that you can take advantage of in your companies. So in the same way Facebook can connect pictures and places and people, and you can do the same thing in a corporate domain between people that work in the domain, documents, interactions, et cetera, and have a graph from within an organization. And so there's unique data attributes or data sets that we bring to the party. The third, frankly, is research. It's the innovation that starts to bring the tools to life that allows sort of every developer and every data scientist to start working with AI and make it part of the core tool set that's available. Now, this is a long journey. We founded Microsoft Research MSR over 25 years ago. And we've been working on different parts of the AI problem set for many, many years. Vision's one of the areas. How do you recognize images? When you build deep neural networks, there are sort of many different ways to approach it. Vision was one of those really tough ones where the more hidden layers you get, the more the signal, essentially, or the information gets diffuse. It goes away. It's hard to work with. In the early days for trying to do images, getting to 8 layers or 10 layers was a big deal. They got to 20. Some of our researchers came up with a methodology that allowed for 152 hidden layers, so something called residual neural networks. So these techniques allows for vision to come to life, or image recognition, and that's become a core standard for how people do image recognition. Speech, we've been working on natural language processing for 20-some years. I always joke I did my first speech demonstration or language recognition demonstration at CES in like 2001 in front of a large room with great acoustics. You can imagine how well it worked, pretty well. We're still doing natural language processing speech demonstrations, but they're getting very good. The switchboard test now has the capability from computers and from AI matching that of humans. All right. Machine reading, MRC, machine reading comprehension is another one. There's a Stanford, there's a squad leadership board, it goes back and forth. Can I read a page of information? Can I understand what's in it? And the techniques or the algorithms get better. So people figure that out. You could read a paragraph, figure out who the quarterback was in whatever Super Bowl, pretty easy. So then they make the test tougher. They put multiple players in with multiple numbers, multiple Super Bowls, it gets tougher. And then they actually make it tougher yet. They add questions that are almost exactly what it's supposed to be, but not quite. So you really have to understand what's in there. So the tool sets are getting better and better, but we've been investing as a company in this research for a long time. And that's where the tools come to life. And as we go through the platform today, the platform comes from building these tools in research for 20+ years. We publish a lot of papers, Google publishes a lot of papers, Facebook does as well. It's early in the season. In some ways, it's like a sales quota, the research are sort of pushed to the end of the quarter, so we'll see a lot come in as we get later in the year. I wanted to just show you sort of, again, mixing together some of the pieces, a piece of research that's going on. It takes sort of the HoloLens and augmented reality. It uses, tools from the AI side, whether it's speech recognition or image recognition in the cognitive services, stitching things together. And it's kind of a fun way to think about sort of research in an ongoing way and bring the two worlds together. Holoportation is the notion of bringing people together from two different areas using HoloLens. So let me run the first video. So we'll set this up.
Using this type of capture technology to connect with family members who are thousands of miles away. And that's exactly what we're going to demonstrate to you right now. My daughter is stood in a similar capture rig somewhere else in our lab. And she's going to holoport into my space, and I'm going to interact with her wearing my HoloLens.
Hi, Bob, I miss you.
Hey, Lilia, I miss you too.
When you coming home?
I'm coming home very soon. Let me get out of your way. Hey, Lilia, you can only hear me, you can't see me, but what are these toys?
I have toys to show you. This one is name is Elmo.
Elmo?
And he can sing.
He can sing, wow. And what about the other one?
The other one is called Tina, and I like it because it has different stuff.
Well, that's so cool. So Lilia, can you climb up on this chair that's behind you? Yeah, climb up. Be very careful. Now I'm going to count to 3 and I want you to jump. 1, 2, 3, jump! That was so cool.
Now that was done using a HoloLens on one half and then just a set of cameras, reasonably low-cost cameras in an array in the room that the child was in. If you take this, you can sort of think about creating a memory and then what you can do with it. So I'll run the second half of this.
But our system is capable of another thing. We can actually record and play back that entire session. Now this is almost like reversing through time. And if I wear my HoloLens device, it's almost like walking into a living memory that I can see through another pair of eyes from all these different perspectives. And because this is 3D content, we can miniaturize it onto this coffee table and experience it in a more convenient manner. And this becomes a magical way of experiencing these live captured memories.
So it's kind of fun to look at sort of the new scenarios and capabilities that are coming along. I mean, we are just scratching the surface, whether it's the augmented or mixed reality part, whether it's the AI part, and how these pieces weave together. The notion of a collection of photos and organizing those is sort of today's world, or videos. The notion of sort of organizing or managing your three-dimensional, sort of life renderings becomes a pretty interesting prospect for the future. Now, dive a little bit deeper into AI specifically. There's 3 things that we're working on as a company. We're sort of plumbers by trade. We build infrastructure. So we're working on a platform for AI. So what developers and data scientists can use to infuse AI into their own solutions or their own products or services they're building. The second is we infuse AI into our own solutions, Windows, Office, Dynamics, etc. And the third is we're starting to look at a new generation of AI-based solutions built from the ground up. And so I'll go through each of these and we'll sort of spend a little bit of time on each. We'll do some demos and some videos. Let's start with the platform. Really 3 pieces to this conversation. Sort of the infrastructure, services specific to AI, and then tooling. On the infrastructure side, as we talked about before, we rely sort of solely or heavily on the cloud. So everything that Scott and Scott talked about is pretty critical. Within that, all of the work we're doing for data is also just a key part of what's necessary. And on data, it's the continued growth and the ability to access and work with data. We started with sort of databases. We worked our way into data warehouses. We're at data lakes. Data is starting to have gravity, so it's at a planetary level. So we're in a good shape relative to working with data. And then all of the tools, whether it's, we have something called Batch AI for working with large amounts of data, Spark, we can work at the edge. All of the sets of tools for working with data and doing the compute as close to the metal as possible. Now below that, the actual chips matter. So CPUs, GPUs, FPGA, the amount of processing required is incredibly intense. And so the more we can do at the metal level, the more we will. And so actually at Microsoft, we spend a decent amount of time looking at silicon. And so working with others, figuring out sort of how to optimize. The whole quantum computing conversation towards the end is all about that next generation. Because if we want to operate in real time with the vast amounts of data we're working with, and sort of what's necessary for real-time AI, we need more processing power. And so with that, we thought we'd do a little demonstration just to show you the difference sort of between CPU and FPGA. So I'm going to invite my colleague, Orville McDonald, to come up. Orville's going to help me with a bunch of the demonstrations today. And so we'll bring that one up first. Morning, Orville.
Morning, Steve. Good morning, Las Vegas. I hope everyone's doing well. That's kind of muted. Good morning, everyone. Is everyone doing well? Great. So it's estimated that by the year 2020, there's actually going to be 44 zettabytes of data. So if you're like me, when you heard that stat, you have to wonder, like, well, what's a zettabyte, and what exactly does that mean in the grander scheme of things? For those of us who are carrying smartphones right now, it has a capacity of roughly 128 to 256 gigabytes. In that, we contain almost our whole life: pictures, videos, contacts, apps. Now take this into account. 1 zettabyte equals 1 trillion gigabytes. So I went through and I did some additional math on it as well, and it turns out that 44 zettabytes will be roughly 6 terabytes for every single person on the planet. So we're talking about a lot of data. And when you start thinking about AI and how to get insights from that data, we have the algorithms, but you also need advances in computing. So I want to show a quick speed test right here. What it does is it does a search for a term across a corpus of documents. So in this case, I'm going to do a search for the term Bing. And the first test I'm going to run is with a single CPU. So just as a reminder, a CPU is a very flexible processing unit that just processes one instruction at a time. You can see that we have a latency of about half a second, and you can see the throughput coming through. It's working, but it's going a little slowly. Anyone who's had to do performance and scalability work knows that when you have a CPU bottleneck, the way that you improve that is you then put the CPU in parallel, so you add more. Right. In this case, we have a bank of 24 CPUs, and we're going to go and run the exact same test. You can see we have a significant increase in throughput, and the latency is about 1/8 of when we use just one CPU. But at the same time, we're now talking about 44 zettabytes of data that's going to exist throughout the entire world. In this case, you actually need something fundamentally different. One thing that we've been playing with at Microsoft is using FPGAs, or field programmable gate arrays, where a CPU tends to be very flexible but not as efficient. An FPGA tends to be very efficient, but also has the benefits of it being able to be dynamically programmed as the needs changed. So now we're going to run that test. And I must warn all of you, do not blink, because if you blink, you will miss this demo. So I'll go through and I'll click on it. You can see that we've now dropped the performance from half a second all the way, or the latency from half a second all the way down to 15 milliseconds. And one thing I want to call out is if you take a look at the scroll bar, you'll notice that it's shrinking pretty rapidly because the throughput is going through so fast. So what does this mean in the grander scheme of things? Well, within our Bing search engine, we actually use FPGAs. And we found that when we took a scale unit that consists of about 22 software units and had a one-to-one mapping between the software unit and the CPU, when we switched to FPGAs, we were actually able to reduce it from 22 down to 6. And the great advantage of that is that we were then able to use that excess capacity to do other things, such as train deep neural nets. So you can see that for a lot of the advances in AI, we're looking at not just the data sets and the algorithms, but also taking a look at advances in hardware as well.
Thank you, Orville. Nice work. And for Orville on the first demo. Can I go back to slides? Perfect. So you should assume at the infrastructure level, we will continue to invest. From the chip level through everything that Guthrie went through on the cloud, you need all of the scaling, you need all the security, you need manageability, you need all the core capabilities that are there on premises to cloud symmetry. You need the ability to work with your own data to ingest other data sets. You need to be able to operate at scale. Now, above that, we've been working on a set of tools that are more specific to artificial intelligence or AI. The first, or the one in the middle, is a set of trained services. So how do we bring sort of cognitive services to life for developers to work with? And cognitive services, think of human cognition, speech, vision, reasoning, understanding, et cetera. And so one of the things we're working on is a set of cognitive services that you could use then in applications or services you're building. The second is a bot framework. And one of the things that we've run into over quite a long time now is, I guess not so long, the spread of applications has grown and grown and grown. So on our mobile phones, we have the core set of apps we use, and then we have a really long tail that occasionally we use. And one of the areas that we've been working on is this notion of moving the discussion or moving the information into a natural conversation. So we talked about conversations as a platform at Build a couple of years ago. The notion of having agents that we can interact with that are part of the natural flow, however we interact, whether it's through a messenger, whether it's through Slack, whether it's through Skype, whether it's through SMS, pick your natural tool chain for conversation and add the dialogue in from the various sets of information we would want. And so when I fly to Paris, I don't necessarily want to download the Air France app for the one time a year I go. I just want to be able to ask, gosh, is my flight on time, or check in. The ability to flow that naturally into Skype or something else, whatever tool I'm using, or I use mail a lot, would be much simpler. So what the bot framework does, it allows us to basically create agents and infuse them into any of the normal conversation platforms. So when we started building these agents, we turned out we had to have a developer for each agent. So one for Facebook Messenger, or one for each of the UI. So one for Facebook Messenger, one for Slack, one for Skype. And so what we did is we create a base level template or base level tool set that can be used to create agents that proliferate into all of them. Now you run into a bit of a lowest common denominator problem with that, but at the same time it allows you to publish once and essentially reach, I think it's 16 channels today. So those two tend to go hand in hand, cognitive services and the bot framework, and we'll show you those in a second. The other side of this is the custom service, Azure Machine Learning, which is more for the data science side and sort of building models and doing sort of machine learning at scale, and I'll cover that a bit more in the tools. Now, on the cognitive services side, we have about 30 of these. Been working on them for quite a while. We bucket those into things used for speech, things used for vision, language, knowledge, search, et cetera. And there's two levels for this. The first is creating a cognitive services that works at a base level. So let's take vision. We have Bing as a data repository. So we have millions and millions and millions of images we can use to train a core model for image recognition. So if I take two pictures and I hold up a cow in front of a camera, on my computer, and I hold up a picture of a giraffe, it knows, okay, that's a cow and that's a giraffe. The basic model works. So the good news is the core is there and people can work with that instantaneously. The second thing, though, is you want it trainable. If I hold up a picture of a cow, great, it says cow. If I say, okay, what type of cow is that? We're not that good. And so that's where a veterinarian or a farmer or somebody who actually knows that space can train a custom model to understand the pictures of different types of cows. I was watching something on hard cider last night because I'm in Vegas, and the guy was saying there's like, I forgot, hundreds of varieties of apples. I'm like, crud, I thought there were like 3. And so if you wanted to train the model to understand which type of apple it is, we built a tool set so developers can take the core, know it's an apple, and then train it, and then build that into your own service or your own app. So if you want to do a custom models for image, for speech, for language, you can go ahead and build those. And so that's a nice way to get the best of both worlds in this cognitive service area. Let me sort of bring it to life in terms of bringing this into a real world experience or a real use application. Let me show you a video from Uber. And so I'm going to run this.
We come to work every day to pilot, test, and launch new technology solutions. Real-time ID check is the latest technology example where we at Uber are constantly developing and testing new solutions to predict, prevent, and reduce security risks in ways that weren't possible before. It's through this partnership with Microsoft that we've been able to develop this technology quickly and ensure that every rider and every driver has an excellent experience. Real-time ID check is a prompt that appears in the driver's app asking them to take a self-photo. We can do a check in real time to make sure that that identity of the person who took the picture matches the account holder who's been approved to drive. Doing that serves a couple of purposes. Drivers know that their identities and their accounts are being protected, and riders know that the driver who they're with has been screened.
Jen?
Evan?
Yeah.
Hi.
Real-time ID is a smart technology. What that means is it factors in and addresses the edge cases. The situation where the driver is wearing glasses or a hat and they weren't in the identification that we have on file. The beautiful thing is it can recognize these changes and ask the driver to remove their sunglasses or retake the photo. The partnership with Microsoft Cognitive Services allowed us to go from idea to execution to implementation across the country in a matter of months. Already, we've been able to make thousands of rides safer, and very soon we're going to be making millions of rides safer through this technology.
So you can see a very real-world application of image recognition, face recognition in this case. There are lots and lots of examples out there. For the next part, can we go back to slides real quick? Oh, never mind, I'm in them. For the next thing we want to do then is sort of take the cognitive services, take the bot framework and start to stitch those together in a live example, the type of thing you might do for any one of your businesses or solutions. And so with that, I'm going to have Orville take over for a few minutes here and build you sort of a mock scenario.
Okay, so one thing that's interesting about when using AI in an application, and if we could switch to the demo machine, please, is that often people want to take what they do without AI and then just do it again, kind of using AI. And that's when you get kind of a bit of a broken experience. So what I want to show here is a Litware insurance demo. And with it, we're actually going to take advantage of the cognitive services to create a unique experience. So we can see here we have a chat window. I'm being prompted. It says, how can I help you today? And let's say that English is not my first language. I speak another language. So I might type in French, bonjour. And then because behind the scenes it's taking a look at the text and detecting what language it is, it's able to respond back to me in a language that might be more native to me. In this case, it's French. Recently, we were in Sweden. So in there, we would say, hey, and I apologize if I'm mispronouncing that. That then comes through in Swedish. So depending on what language I want to use, being able to detect it and then give me an experience that's more natural to me is the better way to go. In this case, I'm a native English speaker. Born and raised in Toronto, live in Seattle right now, so we're going to switch back to there. So now I feel like I'm talking to a person on the other end, even though I'm talking to a computer. So I'm going to ask some questions, like, where are you located? Gives me some information there on kind of where it's coming from. And you can see that I could just type in a way that's kind of more natural for me. I'm interested in what this thing can do, so I'll ask, what can you do? And it goes through and it tells me that it has some information about insurance. And the reason why I'm at this insurance site is because I actually need insurance. So I'll go and I'll just type that in. I need insurance. And you can see that it came back with a variety of results, right? So once again, it feels like I'm talking to a person on the other end, even though I'm talking to a bot. For people who are used to bots, you're probably used to more of a text interface. Well, in this case, we actually have a carousel that shows me different types of insurance products that are available to me. In this case, I want to select autos. So the auto information comes up. I am an existing customer, so I'll say yes. And it's going to want my full name. So for today's purposes, I'm going to use a pseudonym. So I'm going to be Lance Olson. And then I have a choice for smart authentication. So one thing you might remember from the Uber video that we just showed is that you could start to rethink how you do auth. You could do things like facial recognition. You could do voice recognition. There's all these new techniques that are available. But for today, I'm going to keep it simple. And I'm going to do your standard kind of username and password. So I'm going to go and enter my ID. So always scared to enter a password in front of like a few thousand people because they might go take your account over later. But I think we'll be fine there. So right now what it's doing is that it's going behind the scenes and it's actually connecting with a variety of systems, right? Once again, talking about data and how data is everywhere, it's connected to our CRM system. And within the CRM system, it notices that my daughter is about to turn 17 and that we might need to insure. So yes, let's go and include her on that. I get to pick the type of car. So in this case, I'm going to say she's driving a sedan. So what would often happen here, and anyone who's purchased insurance recently for a vehicle knows this, is that you'll tell them the type of car, and then they'll go through and they'll search the VIN number, and they'll get insights on the car that way. But because we're using AI, we could do different things. So here I'm going to tell them the type of car. So I'm going to say it's a Ford, and the model is a Fusion. And the year is 2015. So it's asking me different information about the car, and the reason why it's asking me that is because then when I provide a photo, which I'll go and select here, and of course I have a picture of a Ford Fusion on hand, but really what I want is this Volvo convertible, because the weather's nice, I want to look good while I'm driving down the street, so I'll go and put that in there instead. And what's happening behind the scenes is that the AI is actually taking a look at the picture of the image, and it detects like, hey, that's not exactly a sedan, that's a convertible, right? So you can start to do smart things to really detect whether something's accurate or not. And if you think about kind of your own businesses that you work for, you could think about how you could use image recognition in unique ways so you don't have to deploy people out to go take care of a task. Instead, you could just have the picture come in and then analyze the picture accordingly. So we're not going to use this one. I'm going to keep it real, and I'm going to go put the actual picture of the Ford Fusion. So I'll go through here. So we'll go through and we'll do an analysis there. So it looks like it's having a problem detecting it, but this is where customization comes in. So when you start to see stuff like this, you can start training it to get better and better at kind of analyzing things. But this is the picture I want to use. See, so it's liking the purchase. It's thinking I'm doing a good job. So now what it's able to do is it's able to take my personal history with the insurance company by pulling out from the CRM system, analyze the vehicle I just bought, look at the person who I'm about to add insurance for, and then start to give me a quote. So I look at that. That quote seems really high to me. Maybe I'm cheap, but that's just way too much money. So I'm going to tell them, no way. That is too expensive. Although the flip side is I could go back to Googs later and ask them for a pay raise. But in that case, instead, I'm just going to say that, hey, that's just too expensive. And because we're using emotion APIs behind the scenes, it's able to take a look and say like, whoa, this person's getting disgruntled. Maybe I should move them over to a human agent, right? And many times we have times where we're on calls, we're going through the automated process, it gets really frustrating and we get upset and we just wish somebody could understand our frustration. Well, with AI, you make that kind of possible. Can I see from a show of hands how many people have ever had to write like search engine code or bot code or anything like that? Okay, so there's a few people. So the one thing that you'll recognize is that when you have to type in natural language, because you could be so fluid and say things in so many different ways, being able to capture that tends to be a very difficult task. And there tends to be all these edge cases and it gets really unwieldy. So one of the cognitive services I'll actually show off is something called LUIS. And the great thing with LUIS, which stands for Language Understanding Service, is that as you type in different queries, it's actually tracking behind the scenes kind of what were the queries that were submitted and what were the right intents that matched it. And then in turn starts giving you different recommendations on like different cases that you should test for. So you can see here that it's suggesting some to me. And you can take a look here that I have different intents. In this case, there was the one for I need insurance. And I'll pull it up, and I can start to frame it differently. So that way, kind of over time, your system gets better and better kind of as you go. So this is just a surface level, like what are some of the things you could do with cognitive services, but the one thing I really want to impart is that as you start to develop your AI applications, definitely go out and start to rethink your scenarios and then create something new instead of just applying AI to your existing situations. Thank you.
Awesome, thank you, Orville. Nice one. Go back to slides. You know, I spend a lot of time with organizations, and the conversation comes to what should we be doing in AI? And there'll be three things. One of them is starting to play with cognitive services and the bot framework to create sort of a simple agent. A lot of people do it internally like an HR agent or an IT agent, single turn, reasonably simple. Unilever created an HR bot called Una. It serves their employees. But getting a feel for how to use these tools is sort of thing number one that I recommend for most companies, most people who want to work in this area, because the notion of agents is going to grow over time. And adding intelligence to those agents and figuring out how to work with the tools will be one of the things I think becomes reasonably pervasive in the marketplace. Now, the second one is going to come back to sort of data and custom work you do within an organization or within an industry. So something specific to your industry, your space, and working with the data itself. So on other side of the curve where if sort of cognitive services in the bot framework are development down, the Azure Machine Learning workbench and the tools there are sort of data on moving its way up. So how do I start to work with data, create models, think about machine learning as a basis to then either feed the bot framework and the cognitive services or use it another way. And so there, we've had the Azure Machine Learning Workbench. It's a standalone tool set. We've been working on making it better. We weave that into Azure ML Studio. We'll weave it into VS over time, Visual Studio. There's a set of deep learning frameworks. We make sure those are also all available. We create something called the Cognitive Toolkit. There's TensorFlow. There's Cafe. There are others. There's Chainer from PFN in Japan, and many others. And people say, okay, which one's the best? They all have slight differences. And the truth of the matter is this area is evolving quickly. So whatever we say is best today, we might be having a different conversation in a year. So getting comfortable again with sort of this set of capabilities, working with data, whether it's yourself or you have specific data scientists. Again, we've been creating the tools that come at it from that particular angle. The newest thing, or the latest update, is the Azure Machine Learning Workbench and the work we've done there. A combination of a workbench itself, in particular for data wrangling, because that's where people spend a lot of time, and then experimentation, the ability to build experiments, and then modeling and managing the models across lots of models and instances and machines and people, actually, so you can have different people working on the same model sets. So again, we're going to do a quick demonstration, but this is sort of the other side of the coin. Cognitive services and bot framework, sort of from development down. Now let's go from data up in the platform layer. With that, I'm going to hand it back to Orville again for one more demo on this side.
Okay. If we could get the demo machine, please. So Jabil is actually one of the world's leading manufacturers, and they're actually looking to transition to a more intelligent factory. One thing I'm going to show here is actually the creation of circuit boards. And the reason why this is so interesting is that if you take a circuit board, it gets created along an assembly line. It gets started on one end, a bunch of things happen to it, and then quality control happens at the end of the assembly line. Today, humans and tools take a look at each circuit, but it's a very heavy-duty process. And we think this is an area where AI could actually be a very beneficial thing. So I want to show an example of a circuit board here. And this one actually looks pretty good. And it turns out that this one passes. We'll take a look at a second one, and you can see that there's discoloration on the circuit board. So this one doesn't look like it's quite going to pass. And sure enough, this one fails. One great thing about Jabil is they've actually kept a log of kind of all these different pictures of images of circuit boards that both passed and failed. And I'll show it up here on a notepad. And one thing I want to note is that on the left, it's a comma-separated value file. You see that you have the circuit board ID, but then you also have an image of the circuit board. And in there, you'll notice that often it says pass-fail throughout, but the pass-fail is in different formats. Sometimes you have numbers prepended, sometimes it's appended at the end, sometimes there's parentheses. And can I see from a show of hands how many people here have had to deal with like big data projects? New job? Okay, so there's a few of you. So for those of you who are unfamiliar with it, one of the biggest tasks when dealing with big data is actually data wrangling. It's that whole preparation of it. It's the cleaning of the data, making it consistent, solving for missing values, converting where needed. And arguably, that takes about 80% of the time, believe it or not. So even though data science is one of the hot jobs right now, some people joke that it's actually a digital janitor because you spend so much time just really cleaning your data. Well, thankfully, with the Azure Machine Learning Workbench, they've actually added a lot of tools that make this a lot easier. So here you can see the exact same file that I just showed, but this time it's loaded within the Workbench. And I'm going to go through and clean it. There's a lot of files here, and many of you might be thinking that you now have to sit and watch me clean this up line by line by line. Well, it turns out that's not the case. I have an option here where I could just derive a column by example. It adds it in. And the magic about what's going to happen here is I can see the first one here. Actually, let me scroll this up a bit. Start from the top. So the first one here is a pass. So I'm just going to go type pass in there. Press enter. And what you can see is that behind the scenes, what it's doing is it's actually matching kind of that example I put in and comparing it to the names of all the images and dynamically deciding that, hey, these ones look like they're related, so let me make those ones a pass. You can see down here that there's a failure case, so I'm just going to go and type fail. Once again, it goes through and it updates that. So with just 2 entries, I've actually cleaned up most of the data that I need to do. There's one more. I see there's a special case. This one here has parentheses, so I'm just going to go put pass in there. So just like that, by just changing 3 entries, I've now cleaned up all of my data here. Isn't that a pretty cool thing to do? Wow, that's pretty awesome. And when you start thinking about like all the zettabytes of data that we're producing as a planet, right? Tools like this are going to be very, very important. So what I want to highlight as we move forward through this demo is really 3 things. 1, we're going to clean our data, which we just showed here. 2, we're going to train our models, which is another complicated task that often takes a lot of work. And then 3, we're going to deploy it, and we're all going to do that within a few minutes. So the next thing I'm going to do is I'm going to go and train my model. So today, many people do their experimenting and their training using Jupyter notebooks. And one of the advantages of Jupyter notebooks is that many people are familiar with it, so you get to do a lot of collaboration and a lot of experimenting. Also, because the Azure Machine Learning Workbench works not only on the PC, but works on Macs as well, if some of your coworkers are using a different type of platform, you're able to collaborate with them in a nice, clean way. So I'm going to go through, and I'm just going to start running our workbook. I'll just go and click through a few steps. Great, it's working. So this is the step where we're going to do some of the data wrangling that we just took care of. Looking good. So now this is the step where we're actually going to go and train our deep learning model. We're going to take advantage of some transfer learning, so that way we could accelerate the rate at which we're learning. That looks good. Now we could see this is the image of the very first circuit board that we looked at before. So we know that the correct answer to this one is that it should pass. So let's go and run the next step. And we see that it passes. Another cool thing about taking advantage of the workbench is that I could do experimentation. So now that I know that a pass case works, I also want to see it for a fail case. So I'm going to go and change the image there to image number 2. Let's go and run that again. We see once again, we're seeing that circuit board that had the discoloration. And I'm going to go and run that one more time. And it turns out it fails. And I didn't have to go and restart my notebook from the beginning. I was just able to continue in place and continue on. So everything is looking good. So let's go and continue to run this. Okay, we see a bunch of images. Those look great. We could see our historical results. That looks perfect. Well, one thing you might be thinking about is that running these type of queries or training of models takes a lot of computational power. And I'm just here running it on my Surface. Well, one thing I want to highlight is if you look in this upper right corner, I've actually deployed it behind the scenes to a Linux GPU sitting out in Azure. So within a few steps, you can see within the workbench, I was able to do my data preparation, I was able to train the model, deploy it to the cloud, and then do the cleanup. So let's do one final check just to make sure everything worked. We look at the next circuit board, that passed. We'll look at one more, and that one failed. So you can see that it all worked cleanly. Yeah, yep.
Everybody, it's a good chunk of work in that tool set. So that becomes the second area. 1, sort of working on building an agent. 2, starting to work with data, your own unique data sets, and the ML tool sets that are available. And so that's sort of things 1 and 2. If we come back around now, from a platform perspective, the plumbing is there for people to start working with AI. And you can start applying it to your own scenarios, your own solutions, infusing it into sort of your own products. That's something that we're doing. We're starting to infuse AI into our own solutions at Microsoft. So if you look at Windows, something simple in Windows 10 like face recognition for login. That's using that image recognition. Things like the inking on a surface to make it smooth. Or touch targets getting larger when you're typing on a phone because it knows what you're likely going to spell out. Right? Those are simple things. There's a lot of work that's used in the back end. You can imagine threat protection, both on the client side and on the cloud side. The management of sort of the Skype workload and managing the load balancing. There are a number of places we use AI. Office is a pretty good example of places where we're infusing AI. And truthfully, if we do a good job, you don't actually know we're infusing AI. The product just works better. And so if you take a couple of examples, Word, for a long time, you know, we have a squiggly if something is spelled wrong. That's not AI. And then we have a squiggly if the grammar is not right. Not AI either. But now we'll look at an entire page of text or an entire page of information and look at it and say, hey, the second sentence in the third paragraph looks a lot like the first sentence in the fourth paragraph. You might want to change it, and here's a recommendation. That's using machine reading and artificial intelligence to sort of suggest an alternative. And so we're weaving it into the tool set. Let's go over to the demo machine, and let me give you a very quick example in PowerPoint. So at PowerPoint here, I'm working on a slide. If I want to insert an image, let me pick a picture. I'll pick the crowd showing love. That's you guys right out there today, all right? That's what we like. So the crowd showing love. Now what you'll see on the right, what comes up is a whole bunch of design suggestions that are coming in from PowerPoint itself. So it's using image recognition, it's using sort of tools it has for understanding what the image is, and then layout capabilities. And it does a lot of different designs that we can work with. All right, pretty cool. If I go ahead and if I add another image, let's go ahead and let's go back to Orville's car example. Let's pick his Ford Fusion. Let's insert that because there's got to be a lot of love for the Ford Fusion. That's what I would start with if it was just me, right? And I'd have to sit and sort of muck with how I lay these things out. But here's what PowerPoint Designer is doing. It's creating all these styles that we can work with, right? And so that's a very simple example, but it shows the power of sort of infusing it smoothly. You really can't tell that it's quote AI, but it's doing a great job. Let's pick another example in PowerPoint again. Let's use language translation. So I travel a lot. And when I travel, sometimes they need a translator. Japan does that a lot. And one of the challenges, of course, is I speak very quickly, which drives the translators nuts. But when you go around the world, having translation built in is a much easier way to go. So here I chose Spanish. We're going to start subtitles. And it's going to go English to Spanish. I'm going to click Next. It's going to create a QR code slide that's up front so people can click on the slide and then know that that's available. And then as I go through the deck, it's going to do real-time translation as I go. I was in Sweden about 2 weeks ago, and it was translating real-time. It's not completely perfect, but it's getting pretty good. And so that is a huge sort of very real example of using sort of the language recognition and the language understanding in real life, in a presentation or within one of the applications. Now let me turn this off. Stop that. Now let's go the other way, which is to translate the slides. So as you can imagine, we're a reasonably global company. When we create a slide deck and we send it around, somebody's got to take this presentation and translate it if they're going to use it locally. So let's do the same thing. Let's translate slide, English to Spanish. Let me save. And here we see both of the slides. That's Bill's famous quote, that something around the lines of, it would be nice if computers could understand the way humans operate versus us having to know how to use the computer. And we go to the next slide. It's also translated. So two very simple examples of infusing AI into two products we build today. If we do a good job, you don't really know it's AI, but it makes these things more magical in some ways and really solves very real-world needs or real-world things we want to work on. So let's go back to the slide. So the second area we spend a decent amount of energy then is taking those platforms, the tool sets that Orville showed, and infusing those or infusing AI into the products we build, whether it's Windows, whether it's Office, whether it's Dynamics, even recursively back into Azure and the work we're doing there. Now the third area, is building essentially a new generation of solutions from the ground up. Today we have existing line of business solutions. Most of them are forms over data with some type of rules engine, right? And they become a system of record. And then we have systems of engagement, how we interact with people. There is the movement towards creating these systems of intelligence. So a layer that sits above the record, take all of your data, take external data, use machine learning tools and techniques to create sort of a new layer that allows you to have intelligence about whatever that line of business process is or that line of business application, and use that to go down a new route. And so we've been playing with this at Microsoft. You think about things that are horizontal in nature, so not industry specific, things like forecasting, things like doing sales or customer engagement. One of the core ones that we've been working on is customer care. As you can imagine, we get a lot of inbound requests for help. We do a lot of that through chat, and there are many different types of questions we can get. And today, the current state for most customer care is reasonably tough. Like, if I ask for a raise of hands of how many people like, calling customer care or using sort of chat to get help, it's probably not the highest thing on your list of things to do. And at the same time, it's tough on the other side as well to deliver really great service and make it a positive both for the customers and for the people who do the work. So we've been working on using sort of artificial intelligence to create a bot or an agent specifically to sort of make this a better experience on both sides and to sort of change the business process. Now, you can't sort of hard program this. I can't say, okay, question number 1, I can't log into my PC, you know, and off we go with a hard-coded sort of set of rules. We have to go the other direction. So we actually ingest a year's worth of chat logs, all of the knowledge-based articles we have, all of the web queries, and create a custom graph or custom network out of that set of information that we can then turn into essentially a model like Orville started with, but for language and phrases and questions. And so we had over 1 million records that we've ingested to go build this out. From that, you can build a virtual agent. So if you go up to Microsoft.com today and you ask a question of the agent that's there, right, that is actually run by the tool set that we built. And so it handles about 600,000 queries a week. And it's not just a single turn type of agent. If you say, hey, I can't log into my computer, okay, Windows, you know, is it a Skype question or Office Windows? Okay, which version of Windows? 7, 8, 10. 10, okay, great. Did you try this? Yes. Did it work? No. Okay, did you try this? Did it work? Yes, great. Reinforce the fact that that worked. Did you try this? Did it work? No. Okay, I'm not sure I have the answer. So then do a sort of warm handoff to a human agent on the other side, a little like the litware side of that. Have that agent have an agent assist, so they have all of the information from the chat so far, as well as all the best practices from all the other agents around the world. Once that gets solved, feed that back into the tool set. And then we have a set of visual tools so we can have all of the modeling information so subject matter experts can work on this. And so it's not in some ways the sexiest AI sort of robot or thing that people build self-driving cars, but it's a real world scenario that is very hard to do today. Most large companies and medium companies have to do this at scale, and it's where you can apply this notion of agents and conversational AI into it. And it's not one method. So we have to use machine reading comprehension to build the original model. We have to build custom deep learning models themselves. We build a specialized graph. We do AI authoring to create a real-time conversation. When do I ask another question? When do I propose a solution? When do I hand off? And then we use reinforcement learning. And so at 600,000 queries a week with our service, we have Macy's and HP up and running. So we're doing 40 million queries that we'll do over the course of this year using a virtual agent that's been built off of the platform. And so let me show you the HP side of this.
We are selling a product, we are selling also the excellence in supported services.
Customer support and customer service is a huge priority to the company. We have over 600 million contacts per year. Microsoft's advanced AI gave us an opportunity to look at better ways that we could scale. The virtual agent that's guiding them and answering their questions, trying to get the proper context around what the issue is. If the virtual assistant can't solve their problem, that information is automatically passed to a live agent so they can continue the conversation.
Artificial intelligence may be able to boost significantly the productivity of our agent.
It's going to cut down on call handle times. It's going to cut down on the actual overall wait for the customer.
The dashboard is critical. We're able to understand direct customer feedback, see key metrics around how the system is performing and whether or not it's resolving customer problems.
We were addressing maybe 15 to 20% of issues. We're now expanding that to close to 70 or 80% with artificial intelligence.
Microsoft's advanced AI capabilities is a win for any organization. And the platform that they are delivering allows you to get the scale and capabilities that are needed in order to implement AI in your business. We're looking at what other areas that we can apply this technology throughout our ecosystem as part of our digital transformation.
Give me a tool that allows me to say yes, definitively and effectively, this is going to fix your problem. Bring it on, let's do this right now.
You can learn more about the solution side of this at aka.ms AI Solutions. I think overall, if I come back around, we're building the platform for you and others to work with to start working with AI. All right, we're infusing it into our own products, and we're starting to build the next generation of from the ground up AI-based solutions, sort of thinking about that system of intelligence. I often, again, talk with companies. I say three things. Start working on building your own agent, something reasonable, simple, maybe internally focused, but get to know the tools. Do something specific to your industry with data, whether it's just your data or mixing your data with other data, and start to look for information and patterns that are relevant. And then 3, think about working with us on one of these horizontal solutions. If you have an organization you want to look at customer care at scale, that's a conversation we'd like to have. Now, the last thing I'll leave you with on in this journey is, AI is early. We talk about amplifying human ingenuity. There's a lot of conversations here in terms of what does AI mean for society, for the world. So we're very focused on sort of the ethics of AI as we go along as well. And so we've built a set of principles that we're using as we build our solutions, as we talk with customers and partners, the notion of being designed to assist humanity, to protect privacy, guard against bias, very tricky thing to do when you think about data, being accountable, being transparent. So as we work on solutions and as we work in the industry and across the industry, we want to make sure that we use AI in a way that it's going to amplify human capability and ingenuity, because with new technologies and new areas, change drives sometimes both fear as well as opportunity. We want to make sure people understand the opportunities that AI provides. In that light, I was going to show you one last video to give you a sense of sort of AI applied in a space that's not our everyday business, not our core, but very important to society as a whole, and just one of many examples.
Okay, right, I'm going to try and replicate this here. We're off to a great start. I tend to kind of just avoid doing sketching and writing now because it's not really worth it if you get something like that. Anything you could do that would just make my hand do what I want it to do and to be able to sign my name would be an incredible thing.
How do we even just begin to help her overcome this particular symptom of her tremors and helping her be able to regain her writing ability, her drawing ability? So what I'm doing is I'm making a very rough prototype, and what this board does is I can connect into it through these wires, these tiny coin cell motors. So these motors will vibrate. I personally think that what this is doing is it's short-circuiting whatever feedback loop there is between the brain and the hand that's causing the tremors. So the idea is if you are distracted by the vibration, are you able to write better? I don't know. I don't know.
It's affecting something. I don't quite know what's happening.
I'm on to something, right? I'm on to something.
Jesus Christ.
Oh my God.
It makes me forget that I have a tremor. I've drawn one of them for a long time. I've actually just written my name for like the first time in ages.
I can't believe it.
Mum, it's called the Emma.
Oh, brilliant.
It's got my name on it. Right.
Powerful, powerful video. We're early in this journey, but there's a lot of opportunity ahead of us. The interesting part for Emma is she's actually a designer that works for Unilever on their Una bot, the bot they built for their internal HR system. So there's a nice connection in there. The thing I tell people is, look, we grew up with storage, network, compute, client, server, web. We're intelligent cloud, intelligent edge. My wife and I, we have a 19-year-old and a 20-year-old. You have them grow up with mixed reality, artificial intelligence, quantum computing, blockchain. They're not only going to have different tools to work with, they're going to think differently. Like, you give us AI, what do? We work on customer care, right? We try and think about how to build an HR bot. We do some other fun things. But we have a certain way of thinking because we've been in the industry a long time. You give the next generation this tool set, they'll both think differently and have a different set of tools to work with. In the same way, with compute storage and networking, we had a different set of tools to work with than our parents did, and we sort of reshaped a lot of the businesses and aspects of the world we're in today. So we're just at the beginning of this journey. There's a lot of opportunity with AI. My recommendation is don't try and do everything. It's a little early for that. Don't try and do nothing. It's too late for that. And so finding that nice balance of where to begin working. As plumbers, we're trying to create the tools to make you successful with this. As product developers, we're infusing it ourselves. And as people who build solutions for a living, we're testing this out on both ourselves, and we're ready to work with others on that as well. With that, if you want to learn anything more, you can go to www.microsoft.com/AI. And I wish you a great rest of the show, and thank you for your time this morning.